So let us start with the coding part of artificial neural network. To understand the coding part, we have taken this California housing data, which is readily available in Google Colab. So this red color columns are the input, and this yellow color column is the output. This California housing data, it deals about price prediction of the house. So if I want to read it, I will read it like this. This is the first data or the first row. So this is a house with a longitude of 114.31, latitude of 34.19, and housing median age, the median age of the house is 15 years. The total number of room square area, or in the other some unit, is 5612, and the total bedroom area is 1283. Population in that area is 1058. Household 472A, 572, which is the area located for the maid, and the medium income of that person is 1.4936. So by this information of the house was sold at 66900. Hence it is called as California housing data, or the housing data for price prediction. So as you can see over here, there are 8 inputs and there is one output, and it is a regression kind of problem because the data are a numeric data. So let us just proceed forward. If there are 8 inputs and one output, this is how I can get one of the artificial neural network. Okay, here what I have done is, the input layer, this is the input layer, and the output layer remains constant. So there were 8 inputs, longitude, latitude, and so on, median underscore income, and the output was median house value. Okay, here I have added 2 hidden layers, and in each hidden layer I have added 12 neurons. So it is completely up to me. I can add more than 2 hidden layer, I can add some 20 hidden layer, and in each hidden layer I can add more than one in neuron, or 10 neuron, or 20 neuron, and so on. Okay, so now let us go in Google Colab and let us just try to run an artificial neural network ka architecture. Okay, so I have taken this California housing data. For that, what I have done is, I have gone to this file folder, then I have come to this sample data. From this sample data, I have taken California housing underscore train data. From here I have gone to copy path. After copying the path, I have just pasted this path in the double inverted comma over here. Once I paste this path over here, I can readily get this data. After that, I have done data.head, and in bracket I have written 2. If I am writing 2, I can see only 2 rows of the data. Okay, after that, once I have uploaded the data, I have identified my input, which is x, which is the median house value. I have dropped median house value, as you can see over here. Then I have identified my output, which is median house value. Then again I have done y.head. When you type y.head and you do not write anything in this close bracket, you will always find 5 data in the print command, as you can see over here. If I write 3, then only 3 data it will show, as you can see over here, from indexing 0 to indexing number 2. After that, I have gone for splitting of data, and I have used 30% of the data as my test size. Okay, from this the artificial neural network part starts. Firstly, what we will do is, we will import TensorFlow. Now this TensorFlow is a library in which we have coding of deep learning and other neural networks. Okay, there is one more library which is PyTorch, which gives similar kind of calculations of artificial neural network. Okay, so there are two libraries, TensorFlow and PyTorch. We are going to use TensorFlow over here. Then again we are going to import another library, which is Keras. Now what is this Keras? Keras is the front end of TensorFlow. Okay, and whatever calculation is going on in the back end, that package or library is TensorFlow. Okay, after that I'm importing again sequential. You can see over here I'm importing sequential. Now what is this sequential? Sequential is a package in which all the codes for writing hidden layer is given. Okay, similarly I am importing dense. In this dense part, we can write the number of neurons and what kind of activation function we are going to use. Okay, now after writing all the libraries over here, I am writing model is equal to sequential. We have done the same thing for logistic regression and for linear regression. What we did is, we used to write model is equal to logistic regression. That is, we created an object of logistic regression. Okay, similarly over here I am writing model is equal to sequential, which means I am creating an object for sequential, and then I am writing model dot add. See, whenever you write this statement, model dot add, it means you are adding a hidden layer. See, when we write codes for artificial neural network, we Firstly, add the hidden layer. So we are adding hidden layers over here. We haven't talked about input layer and output layer. Directly we jump for hidden layer. So how many hidden layer I'm adding? I've added first hidden layer. In this first hidden layer, after this dense, 30 is written. This 30 is nothing but number of neurons in that hidden layer. Number of neuron in the first hidden layer. And the activation function that we are going to use is linear. See, during the explanation in the previous lecture of artificial neural network, we had used the activation function of sigmoid 1 upon 1 plus e raised to z. But sigmoid function is always used for classification kind of problem. Okay, because 1 upon 1 plus e raised to z will always give a number which is between 0 and 1. So it is going to give you the answer of probability. But what do we want as answer? We want the answer to be a numeric value. Hence, we use an activation function which is linear. Okay. Again, we are defining one more hidden layer. So this is my first hidden layer I can write. So this is my first hidden layer. Then I am defining my second hidden layer. Second hidden layer. Then again, this is my third hidden layer. Let me go only with this third hidden layer. Okay. I'm just cancelling this one. Now, after defining this three hidden layer, in first hidden layer 30 neuron, 50 neuron, and then 70 neuron, then I'm compiling all this part, which is first hidden layer, second hidden layer, and third hidden layer. I'm compiling all this part by a command model.combine. Optimizer is Adam. For now, I'm not explaining what is this Adam. Let us see in the next lecture. And next part is loss. Loss is nothing but error, as I had explained you in the previous lecture. So the error that we are going to use here is MAE, mean absolute error. After the compilation is done, all the hidden layers are compiled together. How does the model or Python understands what is the input and output? We haven't given any information about input and output. So when we do this model dot fit, as you can see over here, we are passing x train data, which is training data, and we are passing y train data, which is output data. From here, the Python or the model gets the information that there will be 8 inputs in the x train and there will be one output in y train. In this way, this artificial neural network in TensorFlow, it gets the idea how many inputs are there, how many outputs are there, and how many hidden layers are there. After that, we write epoch. So do you remember what is epoch? Let us again jump on to this diagram. Okay, so according to the instructions given in the prior lecture, one epoch is you go in the forward direction, you predict the value, again you come back and change all the weights. Okay, so when you come back and change all the weights, it is one epoch. Okay, so you have to give an instruction to Python that how many epochs you want. So here I am giving the instruction of 10 epochs. Okay, so now let me run it and let us see how does it run. After running this neural network, as you can see over here, the epoch is running. This is my first epoch. Okay, which has run in 3 seconds, and it has given the mean absolute error of 17,200. It is not one, it is 1,73,254. And similarly, this loss or error goes on reducing after each and every epoch, as you can see over here. See, there is possibility that this error may increase in future. Okay, because of wrong selection of the weight, there is a possibility. So instead of 10, let me just go for say 25 epoch. So for 25 epoch, let us see what is happening over here. Now in 25th epoch, the error has reduced to 79,491. Similarly, in real case applications, we can go for epoch up to 1,000, up to 2,000, up to 20,000 as well. But you have to keep it in mind, the more number of epochs you keep, more time will be consumed and higher configuration of computer need to be applied. After that, we go for predicting the model. This is the same thing that we do every time. It has predicted some values. After that, we have gone for sklearn import metrics and we have calculated the mean absolute error. You please understand that this mean absolute error is after training of algorithm. After the algorithm has trained, after 25 epoch is done, then what is the overall mean absolute error? And this mean absolute error is for 25th iteration what has happened. Okay, this mean absolute error is of testing data. Okay, it is of testing data, and the above one was of training data. Okay.